Europe has always experienced summer heat waves. So why do scientists say this one would have been virtually impossible just 50 years ago? A new scientific assessment reveals that it is not unusual weather driving these record temperatures. It is a climate that has fundamentally changed. These findings come from World Weather Attribution Scientific Report 85, released in June 2020's international team of climate scientists, using observational records and climate model simulations. The assessment quantified how human-induced climate change influenced Western Europe's ongoing extreme heat. An identical weather pattern occurring in June 1976 would have produced daytime temperatures approximately 3.5 degrees Celsius cooler than today. In other words, the atmosphere is no longer responding to familiar weather patterns in the same way because the climatic baseline has shifted. Heat waves of this magnitude, once considered virtually impossible 50 years ago, have become around 300 times more likely today. Even since 2003, their likelihood has increased by tens to hundreds of times, illustrating how rapidly the risk of extreme heat has escalated. The warming itself is accelerating. Across much of Western Europe, June is now the fastest warming month of the year. Daytime maximum temperatures are increasing at 3 times the global average warming rate, while nighttime minimum temperatures are warming at twice the global rate, accounting for both temperature and humidity through the wet bulb globe temperature index. Nearly 45% of European cities are exceeding dangerous indoor heat stress thresholds, indicating substantially greater risks to human health than air temperature alone suggests. These changes have immediate consequences for both people and infrastructure. Much of Europe's housing was designed to retain heat during colder climates, making many buildings increasingly difficult to cool during prolonged heat waves. Nighttime temperatures remaining above 20 degrees Celsius and approaching 30 degrees Celsius in parts of France prevent the human body from recovering after daytime heat exposure, significantly increasing the risk of heat-related illness and mortality. The same conditions are placing unprecedented pressure on electricity networks through increased cooling demand while accelerating soil moisture loss, agricultural drought, and thermal stress across forest ecosystems. Natural climate drivers, including the El Niño Southern Oscillation and the North Atlantic Oscillation, explain little of the observed intensity of this event. Instead, the evidence points overwhelmingly to long-term anthropogenic warming. The defining message of this assessment is clear. Extreme heat in Europe is no longer being shaped by unusual weather alone, but by weather unfolding within a permanently warmer climate. As that baseline continues to rise, events once considered exceptional are becoming increasingly likely. Exploring the science behind our changing planet, Environment Eyepiece.